show me this painting.
You'll make yourself ill.
You show me. It's obscene.
That's right, we're back. And today we're going to mix things up a little bit. Up to now, we've been talking about LLMs. And don't get me wrong, LLMs are awesome, and there's still a ton to learn about them. But there's a whole new world of possibilities out there that we haven't even scratched the surface of. So let's talk about diffusion models and image generation and how to cram it all into our chat app. Let's get a sneak peek. Before we dive in, if you haven't seen any of my other videos, I strongly encourage you to check them out. This is of the utmost importance because it pumps my watch hours. Kidding. Sort of. If you haven't seen my other videos, you're going to be missing some important context, and this video is going to build on that foundation. Specifically, episode 1, no, not that one, and then episode 4, and the AI server setup video too. Episode 2 and 3 are thrilling and page turners, so to speak, but not strictly required. Assuming you're all caught up on LLMs and chat apps and accelerated computing, let's talk diffusion. Image generation and diffusion models. Image generation models like Stable Diffusion and Flux are diffusion models. Go figure. Like transformer-based large language models, diffusion models are also neural networks. For a recap of neural networks, see my episode 4 about prompt deep dives. While transformers and diffusion models are neural nets, they operate using different mechanisms. And keep in mind, transformers can be used for things other than language, and diffusion can be used for things other than images. For now though, let's focus on LLMs as representative of transformers and image generation as representative of diffusion. Let's go over the image generation process. We'll start with a prompt and then convert that to tensors using tokens. Note, unlike LLMs, in diffusion models, the prompt serves as a guide during generation, but it is not an essential part of the process. The model can still generate an image without a prompt. It just won't be aligned to any specific instruction. Also, like LLMs have a temperature parameter, some diffusion models have a guidance scale parameter. It controls how creative the generation will be, or said another way, how strictly the prompt will guide generation. After the prompt tensor, we'll start with random noise as a tensor. Then we'll refine this noise tensor in a specified number of steps using the neural network. Finally, we'll convert this tensor to an image. Let's talk about training to better understand how the model is able to do this. For training, we'll start with a labeled dataset of images. We'll then iteratively add and remove noise to and from the image. You can see here we have a dog, and then we're gradually adding some noise to it. This allows the model to learn how to gradually turn a known labeled image into noise step by step. In reverse, the model learns how to remove the noise step by step, recovering the original image. You may be wondering, why noise? Using noise instead of something like fading to black provides more useful information for the model to learn from. If you faded to black, the changes would be too uniform and there wouldn't be enough meaningful variation in the intermediate steps for the model to learn how to reverse it effectively. Also, when adding noise, every step changes the image just a little bit, making changes more gradual. Noise introduces random variation across the entire image. This randomness gives the model a lot of detailed differences to learn from at every pixel, which helps it understand complex patterns in images. Natural images are complex and contain patterns like visual textures and edges that are statistically predictable. Noise disrupts these patterns in a way that's easier for the model to learn how to recover them step by step. Let's recap. First, we'll take a text prompt and convert it to tensors with tokens. Then, we'll start with random noise as a tensor. The neural network will then gradually denoise the initial tensor in a series of steps guided by the prompt tensor. Last, we'll convert this final tensor into a generated image. Let's review some other concepts. Checkpoints are the save state of a model during or after training. Checkpoint file contains the model's parameters, and it can be loaded later to continue training or used for generation. Next, we have low-rank adaptation. It's a technique used to fine-tune models efficiently. Instead of updating all the model's parameters during fine-tuning, LoRa introduces a small, low-rank set of trainable parameters. This reduces the computational cost and memory requirements, making fine-tuning faster and less resource-intensive. In diffusion models, LoRa can be applied to tweak the generation to a specific style without needing to retrain the whole model. Then we have quantization. It's a process where the model weights are approximated using a lower precision, for example going from floating point to integer. This reduces the memory and computational requirements. It can trade off reduced accuracy for faster inference in varying degrees. And that's a quick overview of image generation in diffusion models. Now that we've got a general understanding of the concepts, let's talk about what we actually want to do. Ultimately, we just want to code a basic image gen functionality into our chat app. We're not going to cover advanced image generation options or fine-tuning or anything quite that sophisticated. Before we move on, I should note that if you just want to experiment with image generation, there's tools out there like Webforge UI and Comfy UI that allow you to get up and running quickly without understanding the underlying mechanics. Also, there's a project called Stable Diffusion C++ in the style of Llama C++ that looks really interesting, but I just haven't gotten a chance to play around with it yet. I imagine we'll come back to it soon though. Our toolkit for today is going to be our Part 3 stack with some tweaks, Hugging Face Diffusers library, PyTorch, Stable Diffusion 1.5, Touch of Flux, and of course EC2s with GPUs. You may be wondering why Stable Diffusion 1.5 and not 2 or 3. Well, Stable Diffusion 2 has a bit of a mixed reputation, although they did revise some things with 2.1. I wasn't really keeping tabs on the ImageGen community back then though. Stable Diffusion 3 has a more restrictive license, so 1.5 it is. Also, I think it provides a good balance of decent images and quick generation, and once you get the hang of things, you can always swap it out for a more capable model later on. As for Flux, it's a very capable model and topic du jour at the moment. Enough said. When it comes to browsing for models, Hugging Face is usually my go-to. However, as I was diving into the ImageGen community, I found out that they have a platform called Civitai. Civitai has some overlap with Hugging Face. You can find models on both, but Civit has much more emphasis on the art itself. Me personally, being a coder and not an artist, I think I'm going to stick with Hugging Face, but I thought it was important to mention given how prominent it is in the community. One more thing. It's not my business what you're going to do with these models. Just make sure to check the license and please promise me you're not going to be a knob. Deal? Deal? Okay, let's carry on. First things first, let's actually spin up some EC2s. We're going to be using the AMI we made in the AWS video. It'll jumpstart us with Docker and CUDA and NVIDIA drivers already set up. So let's check this out. And we're actually going to spin up two different EC2s. One is going to be a little bit beefier than the other. That's what we're going to use for Flux. Okay, first one is going to be our smaller one. We'll call this baby bird. AMI from catalog. We're going to use a G4 DNX large. Yep. And I'm saying small, relatively speaking. We are going to allow all, and we're going to use, just to make our lives easier, 100 gigs of storage. That should be everything. Very nice. Instances, let's go back to our images. And let's create another one. Let's, while we're reviewing the code actually, we can pause this so we're not getting charged. And then let's launch another instance and just kind of have it in the background. We'll call this one Big Rig from catalog. And this one is going to be a G6. Let's see, G6, I think it's E. Yeah, G6E X large. This one is going to have the larger VRAM. And it's going to be pricier. Do that. Allow from all. Anywhere. 100 gigs. You got it. And launch instance. Let's go back to our instances, and we'll go back to our image builder just for the fun of it. All right, so Baby Bird is stopped, and Big Rig will go ahead and stop. And all right, now we've got our instances sitting in the background. Let's go ahead and dive through the code. So we're starting with part 5. It's going to be a snapshot of part 3. So this is just going to be our basic chat app, nothing too fancy there. Let's go ahead and add some changes to it, one at a time. The first thing we're going to want to do to our part 5 is we are going to want to change out a few things. So the environment variables, we're going to be on the EC2, so by default, let's use port 80. And then we're also going to be changing our inference backend. Since we're going to be in the cloud, we are going to be running it in a container with CUDA acceleration. And we're actually going to be using Llama C++ for this, just to kind of streamline and simplify things. So that is what is changing in our environment variables. You can see here, inference is just going to point to another Docker container. And then we've got some inference config. By default, we'll use Phi 3.5 because it doesn't take up as much VRAM, and this is just for demo purposes. We're also going to pass in some config for Llama C++, 99 GPU layers to basically max it out. We're going to limit the context size. If you were to do unlimited context, that eats up a lot of unspecified context, I should say, which would inherit from the model. That would eat up a lot of VRAM. So I'm just going to hard code it to 18,000. And then we're setting the port. Also, the embedding model, we're just going to simplify this. The Infinity server expects the namespace model name, and honestly, this is going to be fine to just use the full name, spaced name, as opposed to two different. And that's it. Our git ignore is going to be adding a models directory. That's where we're going to store our model weights. And we don't want to track the models themselves, but we will keep the directory around. Docker Compose, a little bit different from our part 3. You can see now that we're in the cloud, we are going to be using GPU for our web app. This will be in the case of image gen, because we're using Diffusion, Hugging Face Diffusers. Normally this wouldn't do much because we're just calling APIs, but for now we actually are going to do the inference for the image gen in our Python app. Inference as well, so this is now where our language model is. It's going to be pulling from the Llama C++ server, CUDA image. This is similar to the AWS video, so I'll breeze through it a little bit, just some environment variables, etc., etc. GPU. Infinity, again, environment variable change. And actually, yeah, good, okay. Yeah, you can see here we got rid of Ollama, and we are leveraging GPU for Infinity as well to speed up that embedding generation. And that's it. Yeah, not really much here either. Again, for right now, we're just kind of cleaning up some things with swapping out Llama C++. So app, we're just renaming some things. Yeah, we're gonna have a service for the actual HTTP calls versus our abstractions, is what you're seeing here. That's been split out. So if we dive into that in a second, config, just some config changes, requirements. We're removing Ollama and we're using HTTPX, which is just an HTTP client. So now if we take a look at this, we have app LLM and then LLM HTTP client. So app LLM before was merged. It was relying on Ollama. Now it's just going to be making HTTP calls to the OpenAI compatible Llama C++. So you can see here, we're removing some of the lower level config because that's going to be in our HTTP calls. And we're just doing the streams like that. So we've got one less explicit dependency. Now we're just doing wrapped HTTP calls. Yeah, and then if we look at the HTTP client, we can see here it's going to be pointing to the OpenAI endpoint. So you can see where we get a response. We're going to send the parameters as expected by that spec, and stream, same deal. The stream is a little bit different with HTTP because you have to actually parse it out. You have to look for the data adder and stuff like that. So there's a little bit of parsing you have to do, but I kind of like that we're just using HTTP now as opposed to a specific Python library. Nothing much else there. Again, we're just making code changes as needed. For our purposes for this video, since we're doing image gen, we're not going to bother with RAG or chat summaries or anything like that. So we've just got some flags in here. And additionally, we are copying over some AWS deploy scripts from our AWS video that'll just allow us to provision those servers. Okay, all right, so that's the first change set. Let's go ahead and get that off the working changes. Next, in a similar vein, is going to be the embedding service. So right now it was using LangChain and those abstractions, but we can just use the OpenAI spec as well. So cherry pick. Yeah, so now what we're doing is embedding service. Some small changes here. We are going to just be renaming it just for clarity's sake. And that's pretty much all that's here. There's nothing substantive in this diff. App LLM doesn't have any dependency on it. So let's get that removed. You can see it's renamed, so it's harder to tell. And there's actually quite a few substantive changes. Before, again, we were relying on LangChain. But now all we're doing is just calling the Infinity server OpenAI endpoint, compatible endpoint. And it's going to look a lot like that LLM HTTP client we just looked at. So you can see we're on init. We're going to store the embedding dimensions because that's needed for OpenSearch when we're storing the vectors. So we're going to do that when we load up the model. We'll just do an empty encoding embedding and then get the length. And then if you wanted to pass in a string to get the embeddings, we're just, again, going to call the endpoint, right? And then just standard HTTP calls. So there's nothing really fancy there anymore. We've taken out that kind of wrapped library, and it's now just HTTP. And the vector store just needs to change that a little bit, but otherwise it's pretty much the same. There's just some renamed things here and there. Okay, cool. So that's the next change set. Next up, we're getting into the actual fun stuff. So we're gonna take a look at image gen. All right, quite a lot changed here, but let's dive through it. So we're gonna, like I said, in our app, we're gonna be running the diffusers library to generate these images. And we're gonna store them for now on the file system. If we wanted to do this production ready and scale up, we'd probably have a separate service that's S3-like that actually stores the generated images, but for now we'll just do it in our project to kind of keep things simple conceptually. For Docker Compose, we're only going to be changing one thing. We need to volume map the Hugging Face directory, because as we invoke diffusers, it's going to download the models. So we'll just cache those and volume map it so it's persistent. Just some README syntax stuff or some grammar stuff. App is going to be a little bit different. We're going to have an image gen service. And then what we're actually going to do is add an endpoint for image generation. We're going to take a prompt and then generate an image and then create a chat message for that image. So we're not just sending the image back directly because this is a chat app. We are going to create kind of relationships between those. And actually, it's probably helpful to dive over to that next. So we can see here we've added an endpoint for image generation. It's going to be sent through our chat app, and it returns a chat message after generating that image. And there's not really any other substantive changes here, just some wiring things up. Likewise, for config, we're just setting some variables that we can use. Docker file, this is going to be for later when we, not for this video, but later on we'll take a look at PyTorch compilation and stuff like that. So you need some build tools for that. Models. Okay, now we're getting into some stuff. So we're going to add some dependencies here, as you can see. So chat message, what we're adding here is actually to the users. So we're adding some changes to, this is just syntax actually, although we're saying order by, so that's what's changed here. It's just adding an order by, so that caused it to wrap across lines. And for the user, we're adding a list of generated images by that user. So this is going to reference the generated image model. So a user can have a list of generated images. Then, when we're taking a look at a chat, we do not want to serialize the generated images. You can see in our chat history video, kind of diving into these serialization rules. In a chat message, we can have a reference to the generated image model, and that's going to behave like these other references. Same serialization type rules. And lastly, the new model is the generated image model. So what we're storing is some metadata around what prompt was used to generate it, what the file name's going to be, the user that generated it, the chat message that it's getting sent with, serialization rules, helper that when we're referencing it, the string version, and then also a helper to represent it as an image tag. Again, this is just a helper for the chat message where you can call as image tag and then it'll just send it as an image tag. Just a little quick helper. many architectural ways you could do this. Arguably you could keep this image tag out of here and you would do it in a template, and then you would have a template for the model and kind of decouple it. For quick and dirty purposes, we'll just do it this way. So that's the model and relationships. So we're just adding in a new model and wiring it together with chat messages and users. Okay, requirements. Quite a lot going on here. So diffusers, as we mentioned, with PyTorch. Then transformers as well. And again, some of these other ones were specific to certain models or trying to do quantization or also trying to do compilation. So the ones that are most important are going to be torch, diffusers. Torch and diffusers are the big ones, and transformers as well. So after that, we need a way to be able to actually generate these images, right? So that's where our UI comes in. So we're introducing slash commands to our chat interface. Right now, we're only going to have one. It's just slash image. And we're just going to have a list of input commands that we can, add to later on. So that's what this is here. Then the only other difference is when we submit the chat form, we're just seeing if it's going to run a command or if it's going to send a standard prompt. If it's going to run a command, then we'll do the command, submit. Otherwise, we're going to stream the LLM response back. And then if we're doing a command, in this case, we've only got one, we're going to run that image generation command. So the submit now for our chat interface, it's going to have two branches, whether it's just an LLM response stream or now we're getting into slash commands. So that's what this business is. And because of that, because we've got prompt stream and do command, we're just tweaking, again, whether we're triggering loading state is now up here, and then do command and prompt stream are just focused on that. It's separated from the submit handler. And then for our chat form, we're just passing in the list of commands available. And then let's take a look at utils real quick. Yeah, just some helpers like, check if it's a command. The only rule we have right now is it starts with a slash. Then some other syntactical and type pinning changes. Just doing exports inline instead of down at the very bottom. And a debounce. Actually, this is helpful. So debounce in addition to throttle. So throttle is, it lets through every kind of X per Y time frame. So if you were to throttle it so that it's like 1 per second, if you were smashing that button, it would be like 1, 1, 1. Debounce is where you have to, it has like a cooldown period where it won't let it through until after X amount of time has passed. So it'd be like 1, 1, 1, 1, right? So it won't continue to go until that has passed. So debounce is going to be useful for us as we're doing keyboard input, because there's no point in running a bunch of code if the user's still typing. So that's why we added debounce. And then we can see in our chat form, we're gonna pull in some utils. We're gonna have our input commands. We're gonna have some flags for, showing whether the commands menu is available. And then what we have to do is on our input, we're gonna check the key down and input. So both of those. Why do we care about key down? Well, because I wanted to autocomplete it. I was noticing that when I was noodling with this, it was really annoying to type a slash and then have to move my mouse up, click it, move my mouse down, or continue to type the full slash image. So key down, this is just for tab. So if you do slash and there's only one command, you can just tab and it'll autocomplete image. Otherwise, you'd have to type the full thing out or move up the mouse. So that's what key down is for. It's detecting a tab key. So if it was tabbed and the commands are shown, then autocomplete it. And it's just gonna, pick the command that matches the current input. In our case, there's only one, so it'll always be image. For input, this is a little bit different. So for input, we're gonna see if the current input should show the command menu. So if it's gonna start with a slash, and then that's pretty much it. So that's why we're debouncing, because there's no point in running this as the user's typing every single keystroke. And then lastly, select command. Very simple. We're just going to pick one of the commands when the user selects it from the menu. We've changed our placeholder a little bit. Again, we added some additional bindings and event handlers. And then we've got a command menu that has its own event handlers, but pretty simple, right? We're just showing a command menu above. And then just some styling changes. We're popping back in to our Python code now. So when we do our image gen service, our handler, you can see that we're basically going to be doing something similar to prompts, LLM prompts, in that we're just kind of calling some other services. So user submits a /image command. That's going to go here. We're going to get the image gen service. We're going to figure out what the file name should be. So it's going to call image gen, generate image from prompt. And that's going to, we might as well pop over there, and there, and there. So image gen is going to be pretty simple. It's just diffusers. It's going to have some of its own variables. Image directory, that's where we're going to save things. We're going to use float 16. This is supported, I forget exactly in which NVIDIA cards, but it's supported in the newer ones, not necessarily the older ones. And then we've again got some helper variables. For now, we're going to bypass the safety checker just for demo purposes. We're not actually going to do anything naughty, but this is how you would do it for education purposes only. And then also torch compile, we're going to turn this off for now because we're not quite ready to dive into that. So anywhere you see torch compile, this is going to be turned off. Another thing is we can check if bfloat 16 is supported, and this is on even newer NVIDIA cards. And there's a PyTorch helper that will allow you to see if it's available. To give you some background, Babybird, the server, the G4DNX large with a T4 GPU, does not have bfloat. The 6E with the L4S or something like that does have it. So this is why we're putting it behind certain conditionals. So torch compile, we're not going to deal with that just yet. So for the default, we are going to use 1.5, and specifically we're going to use this LCM version, which allows you to generate images in fewer iterations. So it's a lot quicker in my experience. So default is going to be Stable Diffusion 1.5 with this LCM adapter. So we're just going to set this pipeline together. We're not going to care about torch compile again. And then you can see here, this is what sets the pipeline. So it's just doing some configuration. You can see this in the documentation. Okay. Flux we'll deal with in a little bit later, although it's actually pretty much the same thing. We're just constructing the pipeline and returning it. And this is on init. So in our app, when we were calling the singleton for the service, when it creates it, it's going to do this once. And then later on, we can actually call the get image from prompt. So this is what happens when we send that request from our chat app. You can see we've got some properties that right now we're only gonna really be using these two. So we're gonna need a file name. So we're gonna take the prompt and we're going to construct a file name from that. And then we're going to get the directory path, which again, later on, we'd want to use a service to store these. But for now, we'll just do it on the local file system. So that's just going to be whatever we configure as the image user. And then we're going to use our pipeline to actually generate the image from the prompt. And then we'll just save that to the disk, and then we'll return the file name. Which, and then yeah, you can see here, the only thing we had to change in fsutils when we're getting the file name is if it's above the max number of characters, then just truncate it. Which then if we go back to our app, so in our controller, so you can see here, we're just generating the image, we're passing in that prompt. This will save it to disk and return the file name. Then we're going to use our chat manager to then send the image back to the user as a chat message. So we're gonna have to pass in the file name, our images directory, all that good stuff. So if we take a look at chat manager, get generated image and save messages. So here we are going to store the user's original prompt as a message. We're then going to create the generated image model, instance of the model, right? Using that file name, prompt, whoever created it. And then we're going to construct a reply message. That's the system saying, here's the generated image. And then we just need to go back. So that's what'll get responded with. And then that's what gets sent back to the user. And broadly speaking, that is how it works. So we take a string prompt, we run it through our pipeline, that generates an image, saves it to the disk, and then we just wire up some chat messages using some helper classes. So let's go ahead and get this out of the way. Let's deploy it and try running them. Okay, let's first start with Stable Diffusion 1.5 and our smaller server. So we're gonna start this instance and we're gonna need to connect to it. We only care about that. SSH. Yes. Okay. Good. Let us plug this in to our AWS directory so that we can configure this. Copy, paste, rename. Host name, we're gonna use that. Setup. Yeah, let's do that. CD AWS. LS. Setup. Okay, so it's gonna create some things and it's gonna download the model. And it's gonna try just testing the container, make sure SMI is working. Okay, while that's doing that, let's take a look at deploy. Looks good. Okay, Yeah, looks like everything's working. So now let's try doing deploy. Yeah. Deploying code. All right, great. One other thing we're going to do is nifty little tip. If you're using EC2s for experimentation, there is a remote SSH extension that allows you to create a workspace from an SSH connection. That's going to be really handy. Let's just double check that everything worked. So we're connecting using the same connection string. And we're just going to use our app directory because that's where everything's going to live. And I trust myself, and it should look pretty familiar, right? So let's see here. Does this look right? Yes. We need an environment. Yep, because I cloned this, we need to set the environment. So paste, rename. All right, let's make sure this is the right one. 5.3, yeah, that looks good. All right, so now if I do deploy, it'll copy .env. And now if I go back here, we're good to go. All right, so to run this, we would need to cd app. You could do this from the terminal in the code editor as well, but I kind of like having my terminal up, so we do not need to do this with sudo, although sometimes it makes it easier. Sudo docker compose up -- build. We might need to fix some permissions issues in just a second, but let's fire this. Let's go ahead and fire this up. Once this is done, we'll need to run our database commands to be able to seed the DB and do all that stuff, since we're doing this from scratch. Yeah, while this one is running, tell you what, let's also do Big Rig. Might as well save time. So, same deal. Let's go back to our instances. We'll fire up Big Rig and then come back to it. All right, Big Rig. This is, let's do that. All right, Big Rig. We can see, yep, L40, not L4, L40. Lots of VRAM for us to mess around with. All right, deploy and ls, good, docker compose up build, just so that we can get this one up and running while we're waiting for the other one and jumpstart it. Yeah, okay, we need to change some directory permissions. Give it a second. Yeah, okay, that's fine. We'll need to do this on both, actually. All right, so that stopped, sudo chown. Now let's fire this up again. Okay, looks like that's running. Now let's do the permissions fix on Big Rig. Then we'll go back and do the database seeding for both. Okay. And Baby Bird, still installing packages, but should be ready to run those commands shortly. Okay, looks like Baby Bird is ready to go. All right, let's run those commands. This is just going to seed the database. Okay, and database seeded. Let's keep an eye on Big Rig, but for now, let's take a look at this. All right, so if we did everything right, continue to HTTP, yada, 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 and obviously we forgot something. No problem. We forgot to do a local build. Yeah, we'll run those database commands, then we'll sync to BigRig, then we'll sync to Babybird. Oh. I think I saw something. Yeah, all right, let's run those database commands. Database seeded, deploy. Again, for production, you would use CI jobs and you would ignore any of the node modules and only be getting the bundled versions and such. You wouldn't be doing this, so. But for demo purposes, all right, and I saw an error message, so let's just double check. Okay, that's fine, no problem. All right, now if we go back here, yeah, cool. All right, we're good to go. So this is our smaller server. We're gonna stick with Stable Diffusion 1.5. Let's take a look at the output log. Just make sure everything's running. Hi there. Let's just see. Cool. All right. So now we can see here, if I do slash, right, there's only one command. And this is the thing I was talking about with the tab key. Normally you'd have to do that or type image all the way. I'll just hit tab to autocomplete. And let's go with puppy. So this is, the first one's going to be a little bit slower. You can see here in our logs, it's going to be doing the pipeline any second now. Okay, there we go. Yep. Doing that, and there we go. So we got an image of a puppy. Let's try this again. Image and cat. Should be faster now that the pipeline's up and running. Oh. So since we're running the LLM and the image model in one, looks like the LLM is squeezing out the image model just a little bit. You can see here, it's using about 10 gigs of VRAM. Let's see if we can drop that down a little bit here. Let's just double check, make sure we've got flash attention. Yep, flash attention's on. And look. So let's see if we can drop this temporarily. Let's drop this down, the context size a little bit. And let's restart it and see if that lowers our memory usage just a little bit. Yeah, so that freed up about like we'll say 2.2 gigs by dropping that context size down a bit. So let's see, once the inference comes back online, let's see if we can try this again. And keep in mind, this is the smaller server. All right, we're back in the saddle. So image, let's do slash cat. It's gonna load the pipeline. Okay, there we go. Yeah, and that seemed to go a little bit quicker. Video SMI. let's see what we're looking at. 7. So we've got 12. Good. We've got some wiggle room. So now let's do retro vaporwave poster of a dog riding a motorcycle. We'll see what comes out. We're okay, and interesting. I think that's reasonable. All right, let's now take a look at the big server. Okay, let's go ahead and shut down this server. Instance state, stop instance. All right, so that'll close that window. This connection's now done, and let's hop over to Big Rig. There we go. Because the GPU has so much VRAM, it shouldn't be an issue with context size on this one. Pin folder, app. Okay, and we're over here. Chat, connect. That's good. Instance, this is Big Rig. Open address. And we need HTTP. Let's just check and make sure that the LLM's running. Okay, good. It's pretty quick. And let's just see if Stable Diffusion 1.5 is running. Puppy. All right, looks like it. And NVIDIA, SMI. Yeah, and we're not gonna need to worry. Yeah, we've still got plenty of VRAM. Slash image kitten. Yep, all right, so Stable Diffusion 1.5, but what you're probably all wondering is, what about Flux? And that's fair. So let's do that. What we're gonna do is swap out the pipeline. Yes, I trust myself. So if we go to our image gen service, we are going to, where we've got our pipeline here, pretty low tech, but for now we're just gonna comment it out, comment this in, and that's all we should need to do. Our model ID is gonna be Flux, get the pipeline, and then everything else should be the same. All right. Bring it back. We can leave those. Let's see, just as a comparison. So we did puppy and kitten. Puppy. And let's see. Flux is going to take a little bit longer. And yeah, let's just keep an eye on the log messages. Let's take a look at SMI as well. Although I don't know if the pipeline's fully spun up yet. Yeah, not yet. It'll need to, spin it up. Now that the model weights are downloaded, it should be setting it up. Let's see, NVIDIA SMI. Yeah, there we go. All right. And it's getting there. It looks like we'll have to drop the context on this one too. Oh boy. All right, let's take a look. NVIDIA SMI. Yeah, we'll have to drop the context on this one as well. All right, let's do that and then try it again. Okay, where were we? It's environment. Let's do context 12,000, and let's fire it up again. I know, all that waiting for that, but let's do it again. The model file for Flux should already be downloaded. So let's try this again and see how it does. Puppy, come on. All right, yeah, you can see it's already loading up the pipeline. So, and let's see. Okay, all right, we're back, and yeah. Yep, you can see Flux took, the pipeline at least, took up 36 gigs. Yeah, so that leaves us with just a little bit of VRAM left. And let's compare. So this is what Stable Diffusion 1.5 looked like. And then we can see this is what Flux right now looks like. So it's kind of interesting, right? And we're not getting into, you know, fine tunes or anything like that. This is just the out of the box. But now that the pipeline's loaded, let's give it another shot to see how long it actually takes. Yeah, so we can see Flux came back with a kitten. Again, you'd probably want to run some optimizations on this. As is right now, it's taking about, yeah, just under 4 minutes. Well, between 3 and 4 minutes for Flux, whereas as you saw with 1.5 for Stable Diffusion, it was a couple seconds. Again, that said, Flux, there's performance optimizations you can do, torch compile. So this isn't really what you'd want to run it as, but just for intro purposes. And yeah, so for today, I think that'll cover it for image generation. I hope you liked it, and thank you so much for watching, and I'll see you on the next one.